Solar storm alert: when the sun goes wild, and how it affects your daily life. Solar storms are a phenomenon on the sun that can sometimes have far-reaching effects on the Earth. A solar storm is a sudden eruption of energy and matter from the sun. These eruptions can vary in intensity and are divided into different categories by researchers. The effects of solar storms on the Earth can be diverse. For example, they can lead to disruptions in communications, damage or even paralyze satellites, impair the energy supply, or even have an impact on people's health. Research into solar storms and their prediction are therefore of great importance in order to be able to prepare for possible impacts and take appropriate protective measures. In this context, international cooperation and communication are becoming increasingly important. In this context, there are also historical examples of solar storms that date back to the Middle Ages and have occurred repeatedly in modern times. The study of solar storms and their effects on the Earth is therefore an important part of today's space research. Definition of solar storms. Solar storms, also called solar storms or coronal mass ejections, CMEs, are sudden and explosive releases of energy and charged particles from the sun's corona. The corona is the outermost layer of the sun's atmosphere, which has a temperature of several million degrees Celsius and extends far into space. Solar storms can manifest themselves in a variety of ways, such as eruptions of plasma from the sun's surface, ejections of magnetic fields, or explosive releases of X-rays and UV radiation. These events can have a variety of effects on Earth, such as magnetic storms, radiation bursts, and geomagnetic disturbances. The strength of a solar storm is usually measured by the intensity of the radiation it releases or the speed and mass of the particles it ejects. The intensity of solar storms can range from relatively mild events to very powerful outbursts that can have major impacts on Earth. Importance of solar storms for the Earth. Solar storms have a significant impact on Earth, particularly on technology, energy, communications and human health. The main impacts of solar storms are: impact on technology. Solar storms can cause electromagnetic interference that can damage or disable electronic devices and systems. Satellites, GPS systems, power grids and air traffic can be particularly affected by solar storms. Impact on energy supply. Solar storms can also affect energy supply by destabilizing or damaging the power grid. This can lead to blackouts and disruptions in energy supply. Impact on communications. Solar storms can affect communications through electromagnetic interference and disrupt both radio links and satellite communications. Health effects. Strong solar storms can also have health effects on people, especially astronauts and pilots who are exposed to high doses of radiation. Solar storms can also cause geomagnetic storms, which can cause headaches, dizziness, and sleep disturbances in sensitive people. To minimize the impact of solar storms on Earth, it is important to predict solar storms and take protective measures, such as turning off satellites or shutting down power grids during strong solar storms. Plasma crushes Earth's magnetic field. The Earth's magnetic field is an important protective shield against the solar wind and its charged particles, which can hit the Earth in the form of solar storms. But this protective shield is not invincible. During particularly strong solar storms, the plasma of the solar wind can compress the Earth's magnetic field so strongly that it can no longer fulfill its protective function. This can lead to serious disruptions to technology, energy supplies and communications on Earth. It is therefore of great importance to maintain the Earth's protective shield and to understand how it works in order to be able to take timely action if necessary. This requires continuous monitoring of the solar wind and the Earth's magnetic field, as well as the development of technologies and strategies to defend against solar storms. Historical examples of solar storms. There are some historical examples of solar storms dating back to the Middle Ages. Some of the most notable historical solar storms are the Carrington event in 1859. One of the most powerful solar storms known occurred, the Carrington event. British astronomer Richard Carrington observed a sudden burst of radiation and matter from the Sun that reached Earth within minutes. The event resulted in geomagnetic storms that made northern lights visible in many parts of the world. There were also reports of electrical disturbances, such as fires in telegraph offices and failures in telegraph networks. The Maunder Minimum. The Maunder Minimum was a period of time between 1645 and 1715 when sunspots were few and the sun was comparatively quiet. This period coincided with a cooling of the Earth's climate known as the Little Ice Age. The Maunder Minimum is believed to have been caused by a decline in solar activity, which resulted in a smaller number of solar storms. The solar event of 774/775. In the year 774/775, a mysterious event occurred that was documented in many chronicles and reports of the time. It was reported that a bright light appeared in the sky, lighting up the night sky as bright as day. It is believed that the event was due to a strong solar storm, possibly accompanied by a strong burst of gamma radiation. These historical examples show that solar storms have long been known and can have an impact on Earth. Research into solar storms and their effects is therefore of great importance for space research and protecting the Earth from the effects of solar storms. Causes of solar storms. Solar storms are caused by sudden releases of energy in the Sun's atmosphere. However, the exact causes of solar storms are not yet fully understood. Here are some of the main theories and factors that could be responsible for the formation of solar storms. Sunspots. Sunspots are areas on the Sun's surface where the magnetic field is stronger than the surrounding region. Sunspots are closely linked to solar storms, as they are often the places where solar storms erupt. However, the exact connection between sunspots and solar storms is not yet fully understood. Magnetic field of the Sun. The Sun's magnetic field is a major factor in the formation of solar storms. The Sun has a strong, dynamic magnetic field that is constantly changing and sometimes reversing. When the Sun's magnetic field changes, magnetic field lines can become entangled and broken, causing sudden releases of energy. Coronal holes. Coronal holes are areas in the Sun's corona where the magnetic field is open and ejects material into space. When the Earth is near a coronal hole, it can be hit by fast solar wind, which can lead to geomagnetic storms and solar storms. Solar flares. Solar flares are sudden bursts of radiation and energy in the Sun's atmosphere, often associated with solar storms. Solar flares are caused by strong magnetic forces trapped in the Sun's atmosphere that suddenly break free. These factors can all contribute to the formation of solar storms, but the exact interactions and triggers of solar storms are still the subject of active research. The solar cycle. The solar cycle is a regular cycle of about 11 years in which the Sun's activity fluctuates. The sun's activity is measured by the number and intensity of sunspots and solar storms. During the solar cycle, the number of sunspots and solar storms reaches a maximum and a minimum. The maximum is called the sunspot maximum and the minimum is called the sunspot minimum. During the sunspot maximum, more sunspots and solar storms occur, while during the sunspot minimum, fewer occur. The solar cycle is caused by changes in the sun's magnetic field. When the sun's magnetic field weakens, magnetic field lines can become tangled and broken, resulting in sudden releases of energy that cause solar storms. More sunspots and solar storms are observed during solar maximum because the sun's magnetic field is stronger and more unstable at this time. The solar cycle affects Earth's climate, satellite communications, and power supplies. During a sunspot maximum, solar storms may be more intense and bombard Earth with powerful charged particles and radiation, which can cause geomagnetic storms and outages of satellites and power grids. During a sunspot minimum, solar storms are less likely to occur, but there may also be more intense solar radiation, which can affect Earth's climate. Magnetic fields of the sun. The sun's magnetic field is an important factor in the formation of solar storms and other solar phenomena. It is a dynamic magnetic field that is constantly changing and also influences the sun's environment. The sun's magnetic field is generated by the movement of plasma inside the sun. The sun is made of ionized gas, called plasma, which is constantly moving due to the high temperatures and pressures inside the sun. The movement of the plasma generates electrical currents, which in turn generate magnetic fields. The sun's magnetic field has a complex structure and changes during the solar cycle. During sunspot maximum, the sun's magnetic field is stronger and more unstable, resulting in a higher probability of solar storms. During sunspot minimum, the sun's magnetic field is weaker and more stable, resulting in a lower probability of solar storms. The sun's magnetic field also affects the environment around the sun and the solar system. It influences the solar wind, which flows out of the sun's atmosphere and permeates the entire solar system. The solar wind contains charged particles and magnetic fields that can interact with the Earth's magnetic field and lead to geomagnetic storms and auroras. The sun's magnetic field can also affect power supplies and satellite communications when there are strong solar storms capable of generating electrical currents in the power grids and electronic devices. Coronal mass ejections, CMEs. Coronal mass ejections, or CMEs, are a type of solar storm in which large amounts of plasma and magnetic fields are ejected from the sun. These ejections can weigh several billion tons and travel at speeds of up to 3,000 km per second. CMEs are caused by sudden releases of magnetic energy in the sun's magnetic field. When magnetic field lines become tangled and broken, large amounts of plasma and magnetic fields can be ejected into the sun's atmosphere. These ejections can then penetrate the solar system and reach Earth. When a CME reaches Earth, it can cause powerful geomagnetic storms. The charged particles ejected with the CME interact with Earth's magnetic field and can generate electromagnetic fields that can cause blackouts and other damage to power supplies and satellites. They can also cause auroras when they hit Earth's atmosphere. Because of the potential impact of CMEs on infrastructure and technology on Earth, their monitoring and forecasting is carefully monitored by the space weather forecasting industry and governments around the world. Various satellites and instruments, such as NASA's Solar Dynamics Observatory, monitor the sun and help detect CMEs and forecast their impacts on Earth. Effects of solar storms on the Earth. Solar storms can have various effects on Earth, some of which have already been mentioned. Here are some of the main effects of solar storms on Earth. Geomagnetic storms. When charged particles from solar storms interact with the Earth's magnetic field, they can cause geomagnetic storms. These storms can cause power outages and damage to electricity infrastructure. Northern lights. Northern lights are created when charged particles from solar storms hit the Earth's atmosphere and glow in the polar regions. They are an impressive natural phenomenon admired by many people. Damage to satellites. Solar storms can damage or even destroy satellites in their orbit around the Earth. The charged particles can affect the satellite's electronics or cause them to malfunction. Communication disruption. Solar storms can also affect radio communications on Earth, especially in the high-frequency bands. This can cause communication links to be disrupted or interrupted. Air travel. Solar storms can also affect air travel, especially long-haul flights that fly over the poles. Radiation from solar storms can endanger passengers and crew. Health risks. There is some evidence that solar storms can also have an impact on people's health. Higher solar activity may be linked to a higher risk of heart attacks and strokes, and some studies have shown that solar storms may also increase the risk of miscarriage. It is important to understand and monitor the impacts of solar storms on Earth and their effects on our infrastructure and health. Monitoring solar activity and forecasting solar storms are critical to minimizing potential risks and preparing us for impacts when they occur. Impact on technology. Yes, solar storms can also have significant impacts on technology. Here are some examples. Power grids. Solar storms can cause blackouts and damage to power infrastructure. When a geomagnetic storm occurs, it can create an electromagnetic field that induces voltage in long power lines. This induced voltage can cause surges in transformers and other equipment, which can lead to damage and failure. Telecommunications. Solar storms can also affect radio communications on Earth, especially in the high-frequency bands. This can cause communication links to be disrupted or interrupted. Satellites. Satellites, especially those in low orbits, can be damaged by solar storms. The charged particles can affect the satellite's electronics or cause them to malfunction. Such failures can have significant consequences, especially for critical satellites such as weather or navigation satellites. Air travel. Solar storms can also affect air travel, especially long-haul flights that fly over the poles. Radiation from solar storms can affect aircraft electronics and endanger safety. GPS. The GPS Global Positioning System can also be affected by solar storms. The charged particles can disrupt the signals and affect the accuracy of GPS positioning. Computer systems. In rare cases, solar storms can also affect computer systems. This can lead to data loss and system crashes. It is important to understand the potential impact of solar storms on technology and to take appropriate measures to minimize failures and protect systems. This can be done, for example, by using protective devices or by monitoring solar activity and predicting solar storms. Impacts on energy supply. As mentioned above, solar storms can also have significant impacts on energy supplies. When a geomagnetic storm occurs, it can create an electromagnetic field that induces voltage in long power lines. This induced voltage can cause surges in transformers and other equipment, which can lead to damage and failure. Impacts on energy supplies can vary depending on the intensity of the solar storm and the quality of the power infrastructure. In particular, solar storms can cause entire power grids to collapse, leaving large parts of the population without electricity. One example is the 1989 solar storm that caused a blackout in Quebec, Canada, affecting more than 6 million people. Similar events have occurred in other parts of the world, particularly in areas located at higher latitudes and therefore more vulnerable to geomagnetic storms. Various measures are taken to minimize the impact of solar storms on the energy supply. These include, for example, installing protective devices in the power supply infrastructure that can interrupt or divert the flow of electricity during a geomagnetic storm. Monitoring solar activity and predicting solar storms can also help to take appropriate protective measures and minimize outages. Impact on communication. Solar storms can also affect communications, particularly wireless communications, such as satellite communications, GPS, and cellular communications. The electromagnetic fields released during a solar storm can affect the Earth's ionosphere, causing signal distortion or interruption. Satellites can also be damaged or disabled during a solar storm. This can lead to outages of television and radio broadcasts, navigation systems, and other satellite-based services. In the past, solar storms have also caused problems with air traffic controllers and aircraft communications systems. To minimize the impact on communications, similar measures are taken as for energy supply, such as installing protective devices and monitoring solar activity. It is also possible to use alternative communication systems that are less susceptible to interference from solar storms, such as fiber optic cables or terrestrial antennas. Health effects. Solar storms can also have health effects, particularly on the human nervous system. During a geomagnetic storm, electromagnetic fields can affect electrical signals in the brain, leading to symptoms such as headaches, dizziness, sleep disturbances, and fatigue. Mood swings and depression have also been associated with solar storms. Another health effect of solar storms is increased exposure to cosmic radiation. As solar activity decreases, more cosmic rays enter the Earth's atmosphere, which can lead to a higher risk of radiation exposure and related health problems, especially for people who work at high altitudes or fly frequently. There are no specific protective measures against solar storms to minimize the health effects. However, it is possible to minimize exposure to cosmic radiation by, for example, avoiding certain jobs or activities that involve increased radiation exposure or by using appropriate protective clothing and equipment. A healthy lifestyle and sufficient sleep can also help to minimize the negative health effects of solar storms. What symptoms are known in a solar storm? Some symptoms associated with solar storms include headaches and migraines. Solar storms have been found to increase the frequency and severity of headaches and migraine attacks. Dizziness and balance disorders. Solar storms can affect the body's balance system and cause dizziness and lightheadedness. Sleep disturbances. Electromagnetic fields during a solar storm can disrupt sleep and lead to sleep disturbances. Mood swings. Solar storms have also been linked to mood swings, anxiety and depression, heart palpitations and cardiac arrhythmias. Solar storms can affect the cardiovascular system and lead to heart palpitations and cardiac arrhythmias. It is important to note that not everyone experiences these symptoms during a solar storm and that symptoms may vary from person to person. There is also no specific treatment for solar storm symptoms, but one can try to minimize symptoms through relaxation exercises, getting enough sleep, and maintaining a healthy lifestyle. Solar storm and the released X-rays. What effects on the body in the long term? The X-rays and high-energy particles released during a solar storm can also have long-term effects on the body. Increased exposure to ionizing radiation can increase the risk of cancer and other health problems, especially with long-term and repeated exposure. However, most people are exposed to only short-term and rare solar storms, and exposure to X-rays and particles is usually not sufficient to cause long-term health risks. However, for astronauts and cosmonauts who are outside the Earth's atmosphere, exposure to solar storms and cosmic radiation can pose a greater health risk because they are exposed to a higher dose of radiation. To minimize the risk, space agencies use special protective measures and equipment to protect astronauts and cosmonauts from the radiation. Overall, it is important to minimize exposure to solar storms and cosmic radiation when possible and to take appropriate protective measures when increased exposure is unavoidable. Forecasting and monitoring of solar storms. Predicting and monitoring solar storms is an important aspect of preparing for the impacts they can have on Earth. Here are some of the methods used to predict and monitor solar storms. Solar observatories. Special observatories, such as NASA's Solar Dynamics Observatory, SDO, continuously monitor the sun's activity and can detect signs of solar storms. Satellites. Satellites in Earth orbit can measure the effects of solar storms on the Earth's atmosphere and ionosphere and improve solar storm forecasting. Radio wave and magnetic field measurements. Measurements of radio waves and magnetic fields near the Earth's surface can provide clues about impending solar storms. Computer models. Computer models can simulate the spread of solar storms in the solar system and make predictions about their effects on Earth. Warning systems. There are also special warning systems that inform the public about impending solar storms and provide recommendations for protective measures. By combining these methods, scientists and authorities can make predictions about upcoming solar storms and take protective measures to minimize the impact on technology, energy supplies and other systems. Why is it so important to preserve the Earth's protective shield and how do we preserve it? The Earth's protective shield, also known as the magnetic field, is vital to our survival as it protects us from the harmful effects of solar radiation and cosmic radiation. If the Earth's magnetic field is damaged or weakened, these radiations can reach the Earth's surface and cause serious health, technology and environmental impacts. To maintain Earth's protective shield, it is important to understand and monitor the causes of changes in the magnetic field, such as solar storms and other events in the solar wind that can affect the magnetic field. International cooperation and improved communication are also important to improve solar storm prediction and minimize impacts on Earth. To strengthen the magnetic field, there are currently no viable engineering solutions. Instead, we should focus on improving our understanding of the magnetic field and its interaction with the sun and space to improve our knowledge and ability to predict solar storms and other events that can affect the magnetic field. How long does it take for the solar storm to reach Earth? The duration of solar storms depends on several factors, such as the strength of the outbreak, the speed of the coronal mass ejection, CME, and the distance between the Sun and the Earth. However, it usually takes about 1-3 days for the effects of a solar storm to reach Earth after it is ejected from the Sun. Scientists and monitoring systems on Earth can observe the solar storm in real time and calculate its speed and direction to predict when it will reach Earth. Once a solar storm reaches Earth, its effects can be felt within minutes or hours, depending on the intensity and type of storm. It is therefore important that monitoring systems issue early warnings and appropriate protective measures are taken to minimize damage to technology, energy supplies and other systems. Solar observatories and satellites. Solar observatories and satellites are important instruments that scientists use to observe and study the Sun and its activity. Here are some of the most important solar observatories and satellites. Solar Dynamics Observatory, SDO. NASA's SDO is a satellite that observes the Sun 24 hours a day and collects data on its activity, such as sunspots, solar flares, and coronal mass ejections, CMEs. Solar and Heliospheric Observatory, SOHO. SOHO is a joint project between NASA and the European Space Agency ESA to study the Sun and solar wind. It has been in operation since 1995 and continuously monitors solar activity to make predictions about solar storms. Advanced Composition Explorer ACE. The ACE is a NASA satellite located in a Lagrange 1 position that continuously makes measurements of particle streams, magnetic fields, and energetic particles emanating from the Sun's Solar-Terrestrial Relations Observatory, STEREO. The STEREO satellites are a pair of identical NASA spacecraft that observe the Sun and its eruptions in 3D to make predictions about solar storms. HINODE. HINODE is a joint mission of NASA, the Japanese Space Agency, JAXA, and ESA to study the Sun and its impact on the solar system. These instruments and satellites provide valuable data to scientists to better understand the Sun and its activity and to make predictions about upcoming solar storms. Forecasting models and tools. There are several models and tools used to predict solar storms and their potential impacts on Earth. Here are some of the most important ones. Space Weather Prediction Center, SWPC. The SWPC is a division of NOAA National Oceanic and Atmospheric Administration, in the USA that deals with the prediction of space weather and in particular solar storms. The SWPC collects and analyzes data from various solar observatories and satellites to make predictions about upcoming solar storms. Geostationary Operational Environmental Satellite, GOES. The GOES satellites are a series of weather satellites operated by NOAA that are also used to predict solar storms. The satellites have sensors on board that measure solar activity and make predictions about potential impacts on Earth. Community Coordinated Modeling Center, CCMC. The CCMC is a NASA facility dedicated to developing and deploying models to predict solar storms and their impacts on Earth. It also offers an online service where users can utilize forecast models. Solar Flare Alert System, SFAS. The SFAS is a system operated by the National Institute of Information and Communications Technology, NICT, in Japan that allows users to receive alerts when solar storms or other events that have the potential to impact the Earth occur. These models and tools are important tools for scientists and government agencies to warn the public about potentially dangerous solar storms and take appropriate actions to minimize impacts on technology, energy, communications and health. International cooperation and communication. Because solar storms can have global impacts, international cooperation and communication is critical. Scientists, government agencies and private companies around the world work together to exchange and share data and information about solar storms. An important platform for international cooperation and communication is the International Space Environment Service, ISIS. ISIS is a global organization dedicated to monitoring and forecasting space weather. The organization consists of national space weather centers around the world that collect and exchange data and information on solar storms and other space weather events. Another example of international cooperation is NASA's Living with a Star (LWS) program. The program includes a series of missions dedicated to studying the Sun and its effects on Earth. It also participates in international collaborations with organizations such as the European Space Agency (ESA) and the Japan Aerospace Exploration Agency (JAXA). International cooperation and communication are critical to responding effectively to solar storms and their impacts. By sharing information and using shared resources, we can better understand how solar storms form, how they spread, and what impacts they may have on Earth. Measures to protect against solar storms. There is no way to stop or mitigate a solar storm. However, there are measures that can be taken to protect yourself and infrastructure from the effects of solar storms. Here are some examples. Protecting energy infrastructure. An important protection mechanism is strengthening energy infrastructure. This can be achieved by using special transformers and protection systems that regulate and stabilize energy flows on Earth. However, investments in these protection measures are expensive and take time to implement. Preventive measures in space. Another important protection mechanism is the use of satellites that provide early warning of solar storms. This can be achieved by regularly monitoring and predicting solar activity. Such satellites can also be equipped with protection systems that shut down sensitive instruments before the effects of a solar storm affect the satellites. Emergency plans. In the event of a solar storm, there may be a sudden power outage, loss of communication or other serious consequences. An important protective mechanism is therefore the development of emergency plans to deal with such situations. This includes the preparation of emergency power generators, protection of critical infrastructure, as well as an early warning system for the population. Awareness and education. Another important factor is awareness and education of people and businesses to prepare for possible impacts of solar storms. This can be in the form of educational programs or training to learn how to protect themselves from the effects of solar storms. While there is no way to completely prevent or mitigate a solar storm, measures can be taken to protect ourselves and infrastructure from the effects of solar storms. However, implementing these measures requires global cooperation and investment in technologies and infrastructure. Protective measures for the technology. To protect technology from the effects of solar storms, various protective measures can be taken. Some examples are shielding. One way to protect the sensitive electronic components and systems from the effects of solar storms is to use shields made of metal or other materials that can block electromagnetic radiation. These shields can be used in critical systems such as satellites or power grids. Redundancy. Another option is to implement redundant systems that serve as backups in case the primary systems are damaged by a solar storm. This may mean distributing critical systems and data across multiple locations to ensure greater survivability. Shutting down sensitive equipment. In some cases, it may be wise to shut down sensitive equipment or systems during a solar storm to prevent damage. This may mean that certain systems will automatically shut down if they detect signs of a solar storm. Monitoring and early warning. Another important protective measure is monitoring solar activity and predicting solar storms. When a warning is given of an impending solar storm, operators of critical systems can take precautionary measures to avoid damage. Contingency plans. Finally, it is important that businesses and organizations have contingency plans in place to be prepared for outages or damage caused by solar storms. This may include activating backup systems or training personnel to respond quickly in the event of a solar storm. These protection measures can help protect technology from the effects of solar storms and minimize damage. However, it is important to note that no protection mechanism is 100% reliable, as solar storms can be unpredictable and have the potential to have serious effects on technology. Emergency plans and measures. Emergency plans and measures are an important part of protecting against the effects of solar storms. Some examples of emergency measures include stockpiling. It makes sense to stockpile food, water and other essential goods in order to remain self-sufficient in the event of a power failure or transportation infrastructure failure. Evacuation. In some cases, it may be necessary to evacuate vulnerable areas if the effects of solar storms are too severe. It is important that affected people are informed of evacuation plans and routes. Shutdowns. When a solar storm is imminent, power grid operators may decide to shut down certain parts of the grid to prevent damage to equipment and the power grid. However, this can impact energy supplies and other critical systems. Early warning systems. To minimize damage from solar storms, it is important to have early warning systems in place. When a solar storm is imminent, the affected individuals and organizations can be warned so that they can prepare for the impacts. Training programs. It is important that personnel in companies and organizations have training programs in place to be able to respond quickly and appropriately in the event of a solar storm. This includes regularly reviewing emergency plans and procedures. These emergency plans and measures can help minimize the impact of solar storms on society and protect human lives. However, it is important to note that each solar storm is unique and that no emergency response or protective measure is 100% reliable. Research and development of new protection technologies. Research and development of new protection technologies against the effects of solar storms is an important step to minimize the impact on technology, energy supply and communications. Some examples of research and development are shielding electronic devices. Electronic devices can be protected from the effects of solar storms by using shielding materials. There are several materials that can be used to shield electronics, including copper foil, aluminum foil, and conductive textiles. Development of backup systems. It makes sense to develop backup systems to provide alternative power supply and communication in the event of a failure of the main system. Improving forecast models. By improving forecast models, the impacts of solar storms can be better predicted so that affected individuals and organizations can take appropriate protective measures. Developing protection measures for critical infrastructure. Critical infrastructure such as power grids, water supplies and communication systems are particularly vulnerable to the effects of solar storms. It is important to develop special protection measures for these infrastructures. Collaboration between governments, businesses and research institutions. It is important that governments, businesses and research institutions work together to develop effective protection measures against the effects of solar storms. By sharing knowledge and resources, progress can be made in the development of new protection technologies. Overall, researching and developing new protective technologies is an important step to minimize the impacts of solar storms on society. However, it is important to note that it may be difficult to completely avoid all impacts of solar storms because each solar storm is unique. Protection in your own home. Since solar storms can affect power supplies, it is advisable to take some precautions in the event of a solar storm to avoid possible damage to electronic devices in your home. Here are some tips. Unplug sensitive electronic devices such as laptops, smartphones, tablets and televisions to avoid damage from power fluctuations. Use surge protectors to protect sensitive equipment that cannot be removed. Turn off large appliances such as air conditioners, refrigerators and electric stoves to avoid damage from sudden power outages. Have emergency equipment on hand, which may include batteries, flashlights, radios, and possibly generators, to be prepared for potential threats in the event of a power outage. Learn about local emergency plans and be prepared to act quickly in an emergency. However, it is important to note that these measures are primarily temporary and long-term protective measures are needed at national and international levels to minimize the impact of solar storms on technology and society. Protective clothing, which is the right one? There is currently no special protective clothing designed specifically to protect against the effects of solar storms. Most protective measures relate to protecting technology and infrastructure, rather than protecting individuals. However, the effects of solar storms can increase the dose of radiation we are exposed to. In this context, it may be advisable to wear clothing that protects the body from radiation. Here are some tips. Wear clothing that covers the entire body to minimize skin exposure. Wear clothing made of tightly woven fabrics such as cotton, linen or denim, as these materials have a higher density and provide more protection from radiation. Avoid clothing that is loosely woven or slightly translucent, as these materials offer less protection. It is important to note, however, that most solar storms do not pose an immediate threat to human health because our atmosphere and Earth's magnetic field protect us from most radiation. However, if you are in a situation where you may be exposed to a higher dose of radiation, contact a medical professional to discuss appropriate protective measures. Conclusion. In summary, solar storms are a phenomenon caused by changes in the sun's magnetic field and activity. Although most solar storms do not pose a direct threat to human health, they can have an impact on technology and infrastructure. To minimize the impact of solar storms on our technology, there are various protective measures such as emergency plans and measures, protecting infrastructure and developing new protective technologies. Predicting and monitoring solar storms is also of great importance in order to take timely measures. However, Much remains to be done to deepen our knowledge of solar storms and their impacts on Earth. International cooperation and the promotion of research and development are crucial to better prepare for future solar storms and to minimize the risks. Summary of the most important points. Here are the most important points about solar storms. Solar storms are a phenomenon caused by changes in the magnetic field and activity of the Sun. Although most solar storms do not pose a direct threat to human health, they can have impacts on technology and infrastructure. Impacts on technology include power outages, disruptions to satellite communications, and damage to electronic devices. Predicting and monitoring solar storms are crucial to taking timely action. There are various protective measures such as emergency plans and measures, protection of infrastructure and development of new protective technologies. International cooperation and the promotion of research and development are crucial to better prepare for future solar storms and to minimize the risks. Outlook on future research and developments. Future research and developments in solar storm science can help deepen our understanding of this phenomenon and improve our ability to prepare for and respond to future solar storms. Some of the areas where future research and developments could take place include improved forecast models. There is a need for more accurate forecast models that allow us to more accurately predict the strength and duration of solar storms. This can help us better respond to future events and take timely action to minimize damage. New technologies to monitor the Sun. The use of new technologies, such as the use of satellites and solar observatories, can help us better monitor solar activity and improve forecast models. Developing new protection technologies. There is a need for new technologies that can help better protect electronic devices, infrastructure and power grids from the effects of solar storms. Research into the impact of solar storms on human health. Although solar storms generally do not pose a direct threat to human health, there is not yet sufficient research into the long-term effects that the released X-rays can have on the human body. These and other developments could help us be better prepared for future solar storms and better protect ourselves from the potential impacts of these events. What is a blackout? A blackout is a total power outage where the power supply to a larger geographic area fails completely and cannot be restored for an extended period of time. This can be caused by various events, such as natural disasters, technical problems in the power grid, or attacks on the power grid by cybercriminals or hostile actors. A blackout can have serious impacts on society as it paralyzes infrastructure and can affect the supply of essential goods such as food, water, and medical supplies. What shopping list for a blackout? In the event of a blackout, it may be a good idea to make a shopping list of essential supplies to be prepared for an emergency. Here are some things that could be on such a list. Water. At least 3 liters of water per person per day for at least 3 days. Food. Non-perishable foods such as canned goods, dried fruit, granola bars, nuts, canned meat or fish, long-life milk, biscuits and cookies are ideal. Flashlight. And extra batteries. Battery-powered radio or battery-powered radio scanner to stay informed about current developments. Power bank. Or chargers for mobile phones to be able to communicate in an emergency. Lighters or matches for lighting candles or oil lamps. A battery-powered or handheld emergency radio to stay informed of current developments. Warm blankets to stay warm when needed. An emergency supply of cash and small bills in case electronic payment systems do not work. Medicine and bandages. Toilet paper and other hygiene products. It is important to note that the supplies mentioned are only a general recommendation and must be adjusted according to individual needs and circumstances. Basic knowledge. Sun. Basic knowledge about the Sun includes its properties, structure, function, and its role in the solar system. Here is some important information about the Sun. Size and distance. The Sun is a giant, spherical star located at the center of our solar system. It has a diameter of about 1.4 million kilometers, which is about 109 times the diameter of the Earth. The average distance between the Earth and the Sun is about 150 million kilometers, which is called 1 astronomical unit, or composition. The Sun is composed mainly of hydrogen, about 74%, and helium, about 24%, as well as small amounts of heavier elements such as oxygen, carbon, neon and iron. Its interior undergoes continuous nuclear fusion, in which hydrogen atoms fuse to form helium, releasing enormous amounts of energy. Temperature and surface. The surface temperature of the Sun is about 5,500 degrees Celsius. In its core, where nuclear fusion takes place, the temperature reaches several million degrees Celsius. The visible surface of the Sun is called the photosphere, while its outer atmosphere consists of the chromosphere and the corona. Structure. The Sun is made up of different layers, including the core, the radiative zone, the convective zone, the photosphere, the chromosphere, and the corona. Each layer has its own physical properties and plays a role in the processes that take place on the Sun. Energy production. The Sun generates its energy through nuclear fusion, in which hydrogen atoms fuse to form helium. This process releases large amounts of energy in the form of light and heat, which are emitted by the Sun and enable life on Earth. Sunspots and solar activity. The surface of the Sun exhibits regular cycles of activity, including sunspots, solar flares, and coronal mass ejections, CMEs. These phenomena are associated with magnetic activity on the Sun's surface and can have effects on space weather and Earth's communications systems. Role in the solar system. The Sun is the center of the solar system and exerts a tremendous gravitational pull on the planets, dwarf planets, asteroids, and comets orbiting it. It provides light, heat, and energy essential for life on Earth. This is some basic information about the Sun to provide an understanding of its importance in the solar system and beyond. Basic knowledge. Moon. Here is basic knowledge about the Moon. Size and distance. The Moon is the Earth's only natural satellite and the fifth largest moon in the solar system. Its diameter is about 3,474 kilometers, which is about a quarter of the diameter of the Earth. The average distance between the Earth and the Moon is about 384,400 kilometers. Surface. The surface of the Moon is characterized by craters, mountains, plains, and grooves. The darker patches on the Moon's surface are called Maria singular, mare, and are flat, basaltic plains formed by past volcanic activity. The light areas are called highlands and are dotted with craters and mountains. Motion and orbital period. The Moon orbits the Earth in an elliptical orbit and takes about 27.3 days to complete one revolution around the Earth. This period of time is called the synodic month. The Moon's rotation on its axis is synchronized with its orbital motion around the Earth, so that the same side of the Moon always faces the Earth. This side is called the front or near hemisphere, while the other side is the back or far hemisphere. Phases of the moon. The visible shape of the moon changes continuously as it orbits the Earth. These phases, such as new moon, waxing moon, full moon, and waning moon, are determined by the moon's position relative to the sun and the Earth. Influence on Earth. The moon has several effects on Earth, including the tides. The moon's gravitational pull causes tidal forces that affect the oceans, leading to high and low tides. The moon also affects the climate and the stability of the Earth's axis. Exploration. The moon has been visited and explored by various space missions, including NASA's Apollo missions, which brought 12 astronauts to the lunar surface between 1969 and 1972. Exploration of the moon has deepened our understanding of the formation and evolution of the solar system and may serve as a basis for space exploration in the future. Knowledge about the moon is not only fascinating, but also important for our understanding of the solar system and its dynamics. Rights and ownership notice. This audiobook is published and distributed by Testbericht-Institut LLC. All copyrights, publishing rights, distribution rights, audio rights, and related intellectual property rights for this work have been lawfully and exclusively acquired by Testbericht-Institut LLC. Testbericht-Institut LLC is the sole and unrestricted rights holder of this audiobook, including the right to reproduce, distribute, publish, monetize, and publicly perform the content on digital platforms such as YouTube. The original manuscript files, source documents, and contractual acquisition records serve as proof of lawful ownership. The original author and/or their authorized representative, Renovatio LLC, has transferred all relevant rights to Testbericht-Institut LLC in accordance with applicable copyright and publishing law. This ownership applies to all current and future uses of this work, including audio, video, and digital publications. Effective date of rights ownership: the 1st of February 2026. Any unauthorized use, reproduction, re-upload, redistribution, or claiming of this content is strictly prohibited. Copyright Testbericht-Institut LLC. All rights reserved.